Alright, last property. Everybody turn to your last page of notes. It just say chords property number 4. So, this property, once again, I want you to think about it with a common sense mindset. Don't get too stuck on vocabulary words. Don't get stuck on trying to memorize everything. I want you to look at this picture and think about what it's saying. Now, if I had to ask you, FG and JH, before we even read, before we get into any notes, just looking at this picture, do they look congruent? Do they look different? What can you say about FG and JH? Well, to me, they look like they're going to be congruent to each other. And it just so happens that they are. I'm going to go into the property for why. This property says, if two chords are congruent, if and only if they are equidistant from the center. Equidistant. When I say the word equidistant, what two words do they make you think of? Hopefully equal in distance. So yeah, these two chords, they're going to be congruent, but only if they're the same distance away from the center. That's what these lines are showing you, that they're the same distance away from the center. So in this figure above, if LK is equal to KM, meaning if this line is congruent to this line, then I also know that this chord FG is going to be congruent to that chord JH. FG is congruent to JH. That's a property. And when you see this in action, you're going to realize it's much easier than it looks. So let's take a look at example number 1. So I have two chords here, and I see that there's a center E, and it's showing me that they're connecting the center to the two chords. These two tick marks here, that lets me know that this distance is the exact same length as this distance. The distance from the center to the chord AB is exactly the same as the distance from the chord DC in the center. They're equidistant from the center. They're the same distance away from the center. So what does that mean? These two chords are going to be congruent. So I know that this chord, which is x plus 9, has to be equal to this chord that is 3x minus 11. So I can set them equal to each other because they are equal, they're congruent. So x plus 9 equals 3x minus 11. And all I want you to do is solve for x. Exactly how we did an example from the second video. First thing I'm going to do is what? Combine like terms. So I see two sets of like terms here. Let's work with the variable terms first. I see an x and I see a 3x. What do you want me to do first? I can subtract either one. They're both positive, so I can subtract either one. Which one do you want me to subtract? Hopefully set this x. Either one will get you the correct answer. But if I subtract x from both sides, I'm going to be left with a positive variable term. And, you know, that's always easier to work with. We want to work smarter, not harder. So minus x from both sides. X minus x will equal 0. Let's leave that alone. Cancels out. I'm going to bring down my 9. So 9 equals, now 3x minus an x, it's going to give me 2x minus 11. Alright? 2 more steps. I'm going to do what to both sides? I'm going to add 11 to both sides. So negative 11 plus 11, it's going to cancel out to 0 once again. And so 9 plus 11, 20 equals 2x. Last step, divide by 2 on both sides. And so I have 10 equals x. 10 equals x. Alright people, thank you for taking time to watch these videos. So the last thing I want you to do is try number 2 on your own. We're going to come into class and get to work on that. Thank you for doing exactly what you need to do to get to the next level.